All right, hello everyone, this is Mr. Crozier, and I wanted to give you some help on this worksheet that we've been doing for the last couple days. And I'm going to do problems 13, 14, 15, and 16 down here with you. All of the answers again are in these boxes down here. So, all right, here we go. You're going to want to have your reference sheet handy because everything you need to know is in this top box up here. And we just have to take these identities here and use them to simplify. So here we go, problem 13, and you have to just kind of be creative here. And the first thing I see here is we have a lot of we have secants and cosines, and I always try to get everything to sines and cosines first. So let's go ahead and do that. We have cosine over 1. Secant is a reciprocal of cosine, minus cosine over 1 is the top part here, and this is secant, but secant's in the denominator, so if secant is flipped as a reciprocal, it's going to be cosine. So that's usually my first step right there, is to write everything in terms of sines and cosines, and then we can see that things cancel out. And over here we're left with 1, and over here we're left with cosecant squared. And then this should come back to a Pythagorean identity. We know that secant squared plus cosine squared is 1. So if I take away the cosine from both sides, I have sine squared is 1 minus cosine squared. And this right here matches exactly right there. So I can just call this sine squared. And remember, at the end, you're going to want to go back and put the variable in, because this only works if the variable is the same. And in this problem, it was theta. So put that variable back in at the end. If you're not using it up here, that's fine in your work. But your answer, it's sine squared of that particular variable. Problem 14, again. Here we have secant squared, and everything's in secant squared, so I can go ahead and leave that here. But this should clue me into the fact that I have that other Pythagorean identity right here that says 1 plus tangent is secant squared. And if I subtract off this 1 here, now secant squared minus 1 is just going to be tangent. So that's what this denominator is. This is another way to write tangent. So I could write secant squared over tangent squared. Now I'm going to go ahead and put things in my sines and cosines just to simplify it. And secant is reciprocal of cosine, so this is cosine squared. And tangent is sine squared over cosine, but it's the reverse because tangent's now in the denominator. So I can really think of this as sine over cosine squared. Simplify. I'm left to 1 over sine squared, and that's a reciprocal identity for cosecant squared. So this entire fraction got simplified into this fraction, just like the fraction 2/4 can simplify into the fraction 1/2. Large fraction, small fraction. Large fraction, small fraction. Problem 15. What do we go from here? It's already in sines and cosines. It's not going to be a Pythagorean identity, but it is a squared minus b squared is equal to a plus b and a minus b. So this would be sine squared plus cosine squared is sine squared minus cosine squared. And then, well, we should recognize this as a squared plus b squared is c squared, and in a unit circle it's just 1, so this is 1 times sine squared minus cosine squared. And this is just going to be sine squared minus cosine squared. So now we're here. Well, can this be simplified? Well, sure, that's the same thing here. Sine plus cosine, sine minus cosine. However, there's nowhere to go from here because we don't have a rule for these ones. We did have a rule for this one. That's just 1. There is no rule for these, so our simplified version is going to be sine squared minus cosine squared. All right, and the last one. Well, kind of looks like a Pythagorean identity. but it doesn't match any of these. So let's go ahead and put this into sines and cosines. Tangent is sine over cosine, and cotangent is cosine over sine, and everything's gone. And you'll start to get some of these in your head, just knowing that tangent times cotangent, well, these are reciprocals. So reciprocals would be, for an example, 1 over 3 times 3 over 1. Well, that's always just 1. If you multiply reciprocals, it's always 1. So really, once you start getting fast at it, you'll be able to skip this step in here and know that tangent times cotangent, since they're reciprocals, is 1. Hey, and that's our Pythagorean identity again. Remember this rule? Let's write it here. Sine squared plus cosine squared is 1. So if I take this and move it over to here, I have sine squared is 1 minus cosine squared, and that's what I'm using right here. This formula here matches right there, so we're going to call this sine squared. And don't forget to put in the theta. Actually, I forgot it in both of these, so you want to go back and make sure you put in that variable here, because it only works for a particular variable, whichever one you start with. All right, well, I hope this helps on your homework. Tonight's homework for the snow day is a new worksheet, and there are videos for every one of those problems. Have a great day.